you had someone do that before?
I don't know. I just go through and I give grades. So if the better score is above the worst score, then the worst score will supplant the better score. It's the last, well, I do have a PhD. Is that the alternative is a squiggly line?
Yeah.
Okay. Nick, I think you misspelled your last name.
Yeah, it's a little bit scribbled. He's writing fast.
Nick is a little bit scribbles.
That's a good answer, surprisingly. We are using JSON to have a dynamically bounding, that's fine, dynamically bounding cave size that has been previously generated. Otherwise, we could have to use a list of other things from a text file of our own to XML to user input. I don't know what that last part is, but maybe this wasn't as good as I thought, but it's decent. It's at least decent. We use JSON because it's easy to write and easy for the computer to parse. It's I guess an okay answer. It's not really it's kind of missing the point, but alternatively, we could use Java with multiple variables. We already are using Java. We're trying to do something, whatever. Tim, I said you couldn't use XML as the alternative.
I provided more than just that.
You also said Java, which I already said is stupid. You also said HTML, which is XML based.
Wouldn't XML technically be HTML based?
No. You can define HTML using XML, but you can't define XML using HTML because XML isn't a language. It's a language building tool.
Yeah, but you're using the building blocks of HTML.
XML is based on the tag-like language that HTML is.
Yes.
But HTML wasn't the standard version of HTML is defined in XML.
Fair.
But they're not even the same tool. XML is not a language. XML is a tool for building languages. HTML is a language. So it's like comparing apples to 7-Up. Ooh, I love that answer. We'll come back to that one. The second one sucks. The advantage of JSON is that it is very clean. It is a very clean representation of code, and it would be easy for non-programmers to write it to take in for the program. It also is easy to determine which objects are there. JSON is recursive, which is amazing. That's a great observation. It mimics the cave code very well in our example. I'm good with that. The second one sucks like everybody else's. Let's see. The advantage of JSON is it's more structurally sound in its formation. That's a true statement, but why are we using it? We're using JSON because we want every time to have the same amount of rooms in the cave it's organized. What? Is that even English, Abe? Did you give me an alternative, or is that just the white space down here?
That's, yeah.
You're using JSON because it is all organized in a file in one spot. Also, white space for the alternative?
I didn't realize you were supposed to. I didn't hear that.
Oh, that's right. You were late.
Yeah.
So you got the question from Batman there, right? When you walked in, didn't you think that maybe you should ask somebody a little more reliable for the question? You know, like a wall. Ay. Yeah, what's going to be funny? I'm on Jake's now. Let's find out if he cheated. Let's see if he cheated up Jonathan. JSON is recognized as an array and is used for pairing names. You like listen in class at all? Like, what do you do back there? You play video games and stuff? What do you do? Sometimes on Facebook. Sometimes I kind of pass out. You know, I take micro naps, like 1 second naps. It's like, that's called blinking. Oh, I love Fritz's. He leaves up to the imagination.
His answer is whatever you want.
Whatever makes you happy. Well, you know what? Hey, I'm going to incorporate a true Christian worldview in here. It's not necessarily a Lutheran worldview. Well, actually, it's an interesting question. We dealt with this in a Bible study at our church, I don't know, a month ago or something like that, dealing with communion. And it seemed in the group of people that were at this Bible study that based on this group, most Lutherans don't know what they're supposed to believe about communion. Because there's kind of three tracks, right? It is the blood and body of Christ. It somehow magically becomes the blood and body of Christ, or it represents the blood and body of Christ. How many of you are Lutheran in here? Okay, several of you. LCMS? Okay. What are the Lutherans supposed to believe? Well, what do the Lutherans believe? Let me throw it that way.
It's in with and under.
So it's that second one, right? Kind of magically becomes one. Okay? It isn't is. You know, you're not chewing on it, but once you get it in there, it kind of becomes that, right? That's what the Lutherans believe. Catholics, they do the chewing on the flesh thing. And then a lot of the many other denominations do the represents thing. So the reason I thought of that with Fritz's quiz was I don't know which of those is right. I mean, I'm LCMS, but I was born Jewish, so I have an excuse. But at least I know what LCMS is supposed to believe. I kind of take the tract of whatever makes God happy. So, you know, I go up there and I'm like, you know, it's like a gift that Jesus has given to us to remember him. He says that. Now, if he wants me chewing on his flesh, I'm cool with that. Okay? If, you know, he's going to let me kind of eat the cracker thing, and then once it's in, he kind of makes it become the good stuff, I'm fine with that. If it just represents, I'm cool with that. Whatever makes God happy is kind of my position, not the Lutheran position. I don't want to confuse you here. But so Fritz essentially allowed me to whatever made me happy. So I guess it's a good Christian world viewpoint. I guess he gets credit. No, but actually the topic is really fascinating. My wife, who is a far better Christian than me, I just play one on TV. I'm really banking on Jesus having a very, very good sense of humor. But my wife did a whole bunch of study into this because she grew up Nazarene. So, you know, before we became members of the church, we had to like agree with all the stuff. So she read all these books, you know, like crazy, like 700-800 page books written in Latin, studying this. And in the end, she seemed to come to the conclusion that the LCMS position is correct. And my wife isn't a pushover, so I'm going to still go with whatever makes God happy. But I mean, like kind of secondarily,
It's kind of a pushover.
whatever makes the wife says something's true, she's usually right. Okay. Oh, well, why don't we answer the question reasonably? So, why are we using JSON? Well, some of you kind of danced around it. Well, why do we use any sort of data representation language? Well, we use it to represent data externally. So rather than growing our cave, we want to be able to somehow represent our cave in a file that we can then read into our code in some way. Okay? That allows us to have, you know, in our specific case, allows everybody to start with the exact same cave configuration. Level 1 is always the same cave. It would follow level 2 would always be the same cave for everybody, and so on and so forth. So we use JSON, which is a data representation language, to conveniently represent our cave. Some people said it's an object-based language. It looks like a lot like coding. Some of that is very structural. It's easy to write. It's easy to read. All those things are true. Okay. So JSON is a standardized way for representing data. Now, if we didn't use JSON and we weren't allowed to use XML, XML is kind of like a competitor with JSON. We can think of it. It's a little bit older and I would say generally weaker. JSON is more capable of representing more complex types of data, I would think. But it's fair to say XML is a competitor with JSON. So if you couldn't say XML, what would the alternative be? Well, we have to go back to what we did before JSON and XML existed. Well, what we would do is we would create this text file. Maybe it would be comma delimited or something. You know, we'd come up with our own proprietary format for representing that data. You know, maybe we have cave followed by a colon, followed by, you know, an open parenthesis, followed by treasure equals something, comma, room, colon, open parenthesis, you know, whatever it is. We'd have to invent our own language alternative to JSON in order to represent that data. Then we'd also write our own parser to read that in. I mean, we're writing our own parser here anyways because that's fun and it's a learning experience, and to practice the recursion that Val pointed out, the recursive nature of JSON. But there are libraries that are built into pretty much every language today that know how to parse a JSON document. So being a standard, we don't have to reinvent the wheel every single time we deal with a JSON file. We can just use the JSON parser that's built in. Where if you have your own invented language, you know, the Evans made up language, right? If you have your own invented language, now you have to write your parser for that, and you're the only one who knows the language. Okay? And if anybody else wants to use your language, first of all, you have to give them the rules of your language. You have to give them the syntax for it. And then you also have to either provide them a parser or rely on them to create their own parser. Not very convenient to use, right? Okay. So I guess that's kind of maybe the punchline for the quiz. So some people got some of it. I meant that to be an easy quiz. What the heck? Oh, question. Do the Amish have vampires?
I don't know.
I'm still stuck in this whole thing where you said you'd rather be a werewolf than a vampire in that video game. I don't get it. It's actually surprisingly how, well, I say realistic, but like every 30 minutes, my hunger kicks in a little more in the game, so I become weaker. So like, you know, my spells start, you know, hitting less hard, and my regen starts going down. So I got to go hunt people. I have to like go away from questing in the game to go hunt people. Isn't that awesome? Huh? Well, it is inconvenient, but it's the price you pay for being an in-game vampire. That's what I'm saying. I wonder how that works for werewolves, because werewolves don't have to feed, right? They're just awesome.
I don't know how it works in the game.
Well, no, I mean, what's the Amish
You just have
werewolf
to log
lore?
in during a full moon.
Yeah, I mean, during the full moon, you kind of shift, right? And then you're kind of like out of control or whatever, right? But I don't think like to keep your energy level up, you have to. I don't think the werewolf lore says you have to do this. See, we're getting both. We're doing Christian worldview and then made up stuff. but important made up stuff.
So in order to keep the power under the control, if you're an Amish werewolf, you have to go build a barn.
That's the ritual.
Yeah.
That's the ritual of cleansing so you don't shift.
That's it. They're all
Some
werewolves.
guy's out at like 8 p.m. It's like, it's a full moon. I can't get this thing done. I need help. Zachariah!
Maybe that's it. They're all just werewolves. And they keep building barns in order to stop it.
That's a great theory. That all assumes that our ritual thing that we just made up is true.
Of course it is.
Sounded true.
Everything in this class is true.
I agree.
It's true if you think it is. It's like a standard.
Because I don't know how much of that is true, but I believe it. That is a quote from Aquatine.
Yeah.
It's just like Always Sunny in Philadelphia. With the stars.
Now it is actually interesting though that I will become less effective fighting in the game, and I literally, if I could either just continue being less effective and my guy even changes like appearance, like I start looking gaunt and and I have to go. I must feed. It starts calling upon me the hunger.
If you're running around with other people in the game, you just feed off of them.
No, you could. Until you're a level 7 vampire, you can't feed off other in-game players. You have to feed off NPCs. If you feed off an in-game player, you turn them into a vampire. But I can't do that until I'm level 7 vampire. I'm level 4 right now.
And when you're level 7, will you just feed off the people you're on?
Well, I would actually not be smart, because I can only feed off a person once every 7 days. And the going price for a bite is about 25,000 gold right now. I mean, so it wouldn't be convenient for me to bite somebody for free, just to feed. It would be better to zone out of the cave, go and bite a couple of things, and come back. Like bite a bear, maybe. Actually, that doesn't even make sense to me. Why I can't bite bears? I have to bite humanoids. Why can't I bite a bear?
Yeah, blood.
Yeah, exactly. That's what I'm thinking. They have blood.
Human like blood is special.
You have to bite someone that's been not bitten before? Or can you
I
bite
don't-
the same person twice?
Well, I know, because the only way you can bite them is you have to sneak up on them. Just sneak up on them so they don't know you're there. Because once you bite them the first time, then they're kind of like pissed and they fight you. So at that point, they know you're there. There's no sneaking up on somebody who's coming after you. So in theory, I suppose.
Just like passive aggressive, like crap. This vampire's biting me. That's annoying.
Seriously. But I actually found a good feeding spot that they're easy to sneak up on because they're not aggressive towards me.
Are they children?
They are children.
Children.
I only feed off children. No, these guys are they're not enemies, but I can attack them if I want. So they're like yellow when I hover over them. So I can just sneak. I can go right behind them. I don't even have to sneak. Because they don't think I'm going to attack them. And then just, boom! Just drop the vampiric hammer. Oh, this is recorded. This is terrible. We got some good stuff. We got Christian worldview. We got vampire werewolf lore.
Hopefully they only watch
We
the
got
first
Elder
10 minutes.
Scrolls specific vampirism.
Conspiracy of the Amish.
Perhaps the most questionable of all. And you get all sorts of stuff in here. Okay, so let's go into our code. Did we actually start parsing our JSON yet? Well, did we actually start parsing it for real, or have I taken us down some paths that should confuse us at this point? You have to remind me. What have we done? I hate you people. I'm always trying to trick you. Well, here we have a CSC300 parser. We have that written. Boom, 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 boom. Okay, so let's see what we're doing so far in our CSC300 parser. Okay, yeah, so we're moving to some chars. So let's start with this. First of all, let me show you the, here's our cave.dat file. Let's open that. So our cave currently looks like this. I'm going to give us a little more complex one. Because this is much more bestest. Actually, is it? No, this is fine. What we have here is fine. Okay, so here's our caveson file. We actually renamed it caveson. That's awesome. All right, so opens here with an opening curly brace. This is JSON format. Now, I want us to start thinking about the standard of JSON. We want to take this down to its basic structure of JSON. I'll kind of write it in here. Because in order to write a parser for JSON, we need to understand the JSON standard. So I think Amish told us that JSON was an object-based storage language, right? So that's actually one of the advantages of JSON, kind of why JSON came into existence post-XML. Object-oriented languages have become very popular, and JSON is very convenient for storing objects. A, it has the power of also storing arrays, even though we're not dealing with those here. And B, it looks a lot like our object-oriented languages. Those are advantages. So since typically it would be a programmer who is actually parsing the JSON, a programmer would be used to working with those symbols. Now, from Val's perspective, though, she mentioned that JSON would be easy to write as a human being, let's say, non-programmer. Probably true, but you might argue that it's not as easy to write JSON as it might be to write XML. XML might look a little bit less cryptic, maybe. You know, it's like, here's an opening tag, here's a closing tag. They both say the same thing. This one has a slash, put the crap in the middle. Right?
Go SQL.
Huh?
You could cheat and go SQL.
SQL wouldn't be a storage representation language. It's a query language.
You could use it in the same sense. But
You can create an SQL-like language
Yeah.
I mean, that's true. That could be your proprietary Haxton protocol or whatever. It would actually be quite difficult to write a parser for that. There's a number of layers that go down. SQL is quite a complex language. Yeah, most people who, when you guys finally get exposed to SQL, it's a query language for querying databases. 99, I'm just making up numbers, but let's say 99% of the time, you use like 2 SQL commands. You know, select whatever from a database or insert into database. That's it. But SQL supports about 500 other commands and all this complexity in there and stuff like that. So, you know, at the simplest level, the simple SQL, it would be completely doable. I should have totally drank this cookies and cream one first. This is delicious. It's like they took an entire Oreo and they crumbled it up in there and then just filled it up with ice cream. Then made it hot. Could be the sugar actually counteracts the caffeine. So now the JSON standard, since it's an object-based language. Now, at a glance, when we look at it here, we're not necessarily seeing the pattern. This whole thing is a JSON document. The whole thing contains a single object. Okay? This particular object is a cave object. This cave object contains one variable. That's the variable name. This is the separator between its value. Here is the value of that variable. The value of that variable is JSON, a JSON value. Okay? So this is another JSON value. So now we're getting into this idea where Val said it's recursive. Okay? We're going to parse JSON up here. While we're parsing JSON, we're going to look for a variable. We find a variable, that variable has a value. Oh, it's also JSON. How do we parse JSON? We call parse JSON. So we'll parse that. This guy has a variable. This variable is not JSON. That variable happens to be a string. So how do we do that? Get the string. Parse treasure or something like that. We know we have more variables. Why? Because there's a comma there. Find the next variable, room. Its value is JSON. How do we get the value? How do we parse JSON? We call parse JSON. Another recursive call. So now we have a recursive call inside of a recursive call inside of a recursive call. And none of them have finished yet. We're in the middle of them. So we're in this room now. We find a variable, treasure, has a normal value. Get it. Hit the comma. Comma says more variables. Find the next variable. This guy's a room. We get its value. Its value is JSON. How do we parse JSON? We call parse JSON. So now we've called parse JSON again. Put everything else on hold. This guy has a variable. It's a type treasure, which means it has a normal value. We do not have any more variables. How do we know? No comma. So we're done with this particular call to parse JSON. So we have finished processing that guy. Move to the next variable. How do we know there's another variable? We found a comma. Here's our next variable. Here's its value. It's JSON. How do we parse JSON? We call parse JSON. This guy has a variable. Treasure. We get its value. Are there any more variables? No. No comma. So we're done with that call to parse JSON. Then we hit the end of this call to parse JSON. Because we have no more variables. How do we know? No comma right here. So this call to parse JSON is now done. Do we have more variables? Yes. Why? Because we have a comma. Go to the next variable. Get its value. What's its value? It's JSON. How do we parse JSON? We call parse JSON. Get the first variable, treasure. Get its value. Are there more variables? No. No comma. We're done calling parse JSON on this. Are there more variables? No. No comma. We're done calling parse JSON on this. Are there more variables? No. No comma. We're done calling parse JSON on this. Does that make sense? So if we were to write the generic version of this, JSON is an opening curly brace followed by, well, here we'll put it in double quotes, a var name followed by a colon followed by a var value. Then optionally, so usually square bracket means optionally in formal languages. So you don't actually have a square bracket in there. Optionally, a comma followed by var name, colon, var value, 0 or more times. That's what the asterisk means after that. Okay? Followed by closing curly brace. Var values can be, they could technically be arrays, but in our language they can't. So let's just keep it simple. In our language, var values can be either a string or JSON. And this is the definition of a JSON value. So what I just wrote here, minus the array syntax for JSON, which is actually would not make this more difficult, really. I mean, it would be, you know, half of a line additional, but I don't want to put it in there because we're not using it. This is the entire definition of the JSON language. Pretty simple. Literally, the entire definition of it is on the screen right now. And I've actually added some commentary. This is commentary telling you what var values can be. They can either be strings or they can be JSON. Make sense? So this is, when you look at it in this case, that seems really simple, doesn't it? A JSON object, as I've represented it here, has at least one variable value pair in it. Technically, the JSON standard would allow you to have 0, but that would be really a waste of time. Why represent nothing in JSON, right? So it's at least one variable value pair followed by optional 0 or more, that's what this asterisk says, 0 or more commas followed by variable name, variable value pairs. That make sense? So we always know we have another variable if we see a comma. This comma means you have another one. That make sense? Okay, so given that, and I know we've already written a bunch of this, but I'm actually going to gut our code to write this more simply. We actually won't write it substantially differently. We're just going to rename some methods, so I think it'll make more sense just to start from scratch on it. This won't be a big deal. Okay, so here is a representation of our cave in that simple language we just described. So if I come back to my Json parser, and let's see here. We already wrote move. Oh, that's going to be helpful. We'll leave move to char there for a second. Process cave. I don't like process cave. Screw that. Okay. All right. You know what? I'm actually going to get rid of move. Well, I'll leave that. It's fine. It's fine. Move to character, we'll move to char, we'll leave. Now remember, the way we're handling this is we have this variable cur pause. Cur pause starts at 0. Okay? Cur pause at all points in time tell us where we are in this document. So when cur pause is this number, that means we're at character, whatever number this double quote is. And as we walk through this, cur pause keeps incrementing through our code. Does that make sense? So at any point in time, cur pause points to our current program counter. The character in our program the character in our JSON that we're currently looking at. Okay, now, when we first call parse cave, so let's go, everybody relax, Json parser. So we're going to go ahead and call parse, we're going to write a method, private void, actually I'm just going to write a method here called parse. That's kind of what will start the thing, and this will be a public method. So when we tell our Json parser to start, we are going to tell it to parse, and parse will do whatever parse means. Okay, so we'll leave that here for a second. Now I'm going to write a bunch of private methods. So the public interface for parsing with our Json parser is this public parse method. Then we have a bunch of private methods. We're going to start off with these being void. Later on, this is going to be cave. Because ultimately, parse cave should result in a cave object, right? But for right now, we're going to have it be void. Private void parse cave. Now, remember, and here, what does parse do right now? It calls parse cave. That's all that guy will do for right now. Later on, we're going to actually update our JSON to be a collection of caves. You know, because when we release this game into the wild, you know, we're going to want to provide the first 1 million levels. Correct? Well, maybe 2 million. How far do you think people get in this?
6
That's a good estimate, so we should double that to 12 million caves.
million.
Okay. Huh?
Why stop there?
Well, we need to have a version 2.
DLC. $10 DLC.
In-app purchase. for PDF maps of the caves. Artists rendered. like the game is like just like super ghetto on the iPhone or Android, where I mean it's literally just like, you know, the cave is like a square. It has like a little gold circle for your treasure. You pick it up, and then your extras are just like white boxes at the bottom. You know, and then you could like in-app purchase these super high definition, like artistically drawn PDF maps. Shows vampire locations. It's gonna be awesome when we start inserting vampires in here. When you go into a room and the vampire feeds off you, he's gonna steal some of your treasure, and he's gonna randomly put it in other rooms in the cave.
Are we gonna have wood chippers?
You betcha.
Are the wood chippers going to be on your side so you can fight vampires with wood chippers?
No, but vampires can fall prey to a wood chipper as they move through the. So you might enter a room that has pieces of vampire in it. Do you expect anything less in my class? You see it. Do we have bitcoins in ours?
Yes.
Is that our treasure? You see a bitcoin and 4 vampire fingers. It's possible that on like the Wiccan market, vampire fingers might have like a value. So as we go and we preach the gospel to the Wiccans, we can also then sell our sell our vampire fingers. You know, I don't know, for their whatever brews they're making or something.
Technically, if you drink the vampire blood off a vampire finger, don't you become a vampire too?
Not according to the TV show True Blood. You just get like superpowers like a drug. You get like all hyped up. Don't you know anything?
Well, True Blood it can't be
It's on TV. It's true.
just like the internet.
Right.
Everything's there.
Actually, the True Blood. How many of you have seen the True Blood show? It's actually it's very interesting. It's a new twist on the vampire story.
Isn't that like the lovey, steamy, sexy?
Well, no, that it's just like Game of Thrones from that perspective, yeah. But move past that into like the storyline of it. The idea is if we assume vampires are real, and we're in this world now, and it's become known that vampires are real, but a company has released a beverage called True Blood, and True Blood is this synthetic blood so that vampires no longer have to feed off humans. And now you have it's like politics of vampire kind and humankind trying to coexist, and you know, then you still have the rogue vampires that only want the real thing. You know, it's an interesting twist on the whole. You know,
This new stuff tastes plastic.
well, yeah. So I can't stand this crap.
Diet blood.
And then you have a whole economy of like humans that will like provide themselves to vampires, and the vampires like sip off of them, so they don't kill them. It's very interesting. Whole new spin on things. What was I talking about? Oh yeah, vampires. So, all right. So Parse. This is a pretty interesting. This is a pretty interesting class recording. That means a lot coming from me. So Parse is going to call Parse Cave. What does Parse Cave do? Why do I keep thinking it's on a different screen? Parse Cave is going to come into our JSON, and it needs to move past this opening curly brace to position ourselves inside of the first cave object. Correct? In this case, we only have one cave object. Okay, so we need to move ourselves to this opening curly brace and then one pass so that we can then go and process the variables. Because again, we're dealing with this standard. JSON is a collection of one or more variable value pairs. That's what JSON is. Okay? So first thing we're going to do is we're going to use our little move to char method. This dot move to character opening curly brace. So that will move us to cur pause being right there. In this particular case, since there's no spaces before it, literally moved us nowhere. Then we want to move one past that. So what does this say? This says position ourselves before first variable within this cave. That makes sense? So we've just updated our program counter, curpos, to move it to the position that's beyond the beginning of the that's beyond the beginning of the what am I talking about? I got very confused. I started thinking about vampires again. Who would win in a fight, vampire or werewolf? Vampire. You're right.
It depends. I think it depends on what flavor of vampire and werewolf that you're talking
I
about.
mean, what flavor?
No, it's very long as Twilight.
What kind of sicko are you?
It depends on what kind of vampire you're talking about.
We're going Twilight vampire.
Twilight vampire, definitely werewolf.
Who actually won Twilight?
Actually, I don't think that's true.
No one finished it. No one cares.
It seems to me like if you from the Twilight thing, the if you have a single vampire against a single werewolf, I think the vampire wins every time.
All the werewolf has to do though is bring him out in the sun. Then
Then everybody else
is going to try and kill him.
No, I agree. That's a true statement. But you know, in an equal setting, since they're both neither of them are weaker in at nighttime, and they both can see at night. I don't think I think of a single vampire always beats a single werewolf in the Twilight world. I think the vampires are substantially more powerful because that's why the werewolves hunt in packs. Where vampires can be, I mean, I would say a vampire probably could take on like 3 werewolves at once. Then it becomes much more of an even fight. That feels like the correct number to me. Christian world. Fritz, I'll give points for anything. You know, you missed the quiz yesterday in compilers. I know, but you still missed the quiz. It probably wouldn't have mattered. It was hard. So I'm just saying, you should like write in comments like, give me the 5 for Christian world. You'll just say, look, I learned more about the Bible in this class than 18 years in church. All right. So, parse cave. We're going to move to the opening curly brace using our little method we wrote up here. Then we'll move 1 past that. All right. Now, what do? Because of our pattern of JSON, we know that we have at least 1 variable value pair. So we need to find the next variable. Where is the next variable located? Wherever the first opening curly brace is. I'm sorry, first opening double quote is. Relative to where we are now. Okay, so we're going to write a method. Private void find next var. And actually, I'm going to have it return a string, not a void. I'm going to have it return the name of the variable. So for instance, it would return treasure or room in our language. Those are the 2 possible variable names we have. Actually, let's say find next var name, because we're also going to have a var value. Okay, so find next var name needs to get us the name of the next variable. Well, if we're looking at our JSON, we want to move here, then collect all the characters until we hit another double quote, and this is our variable name. And we want to make sure we leave ourselves after the closing double quote. Curpos needs to leave after that. That way we know our value starts with the opening curly brace. Okay? So we'll move to the opening double quote. And we know we're going to have to build up our variable name inside of a string. So we'll start off as the empty string. This dot move to char. What char are we moving to? The char double quote. Okay. Then we'll move 1 past that to put us at the first character in our variable name. Then we're going to have a while loop to collect the name of our variable. So while this dot JSON dot char at this dot cur pause is not equal to the corresponding closing double quote, as long as we haven't hit that double quote yet. So just to show you what we're doing here, I have moved to the beginning of the variable, then moved one past that. So I'm sitting at the very beginning of our variable name. So I'm going to keep collecting characters until I finally hit the closing double quote. That's what this while loop says. This while loop says, keep spinning through here as long as we have not hit another double quote. Inside here, we're going to say var name plus equals this dot json dot char at this dot cur pause. So we'll collect the character. Then we'll say this dot cur pause plus plus. Move forward one. So to interactively show you this loop, we start off here, moved one forward. While that character is not a double quote, which this first time through it's not, correct? Well, that's not a double quote. Concatenate the R onto our var name. Then increment cur pause. Now we're at that character. While that character is not a double quote, concatenate it onto var name, increment cur pause. While that character is not a double quote, concatenate it onto var name, increment pause. While that character is not a double quote, concatenate it onto var name, increment pause. That character is a double quote. So what are we going to do? We're going to fall out of our loop. Var name is currently equal to the string room. Okay, if this was the part of the program we were in right now. Now, before I can return the var name, though, I need to shift myself one past that, so that I'm sitting beyond that closing double quote. That way I don't accidentally interpret this as the beginning of another variable. Okay, so I'm going to put myself in that position right there. We do that by saying this dot cur pause plus plus. Remember, all hard programs are made up of a bunch of easy parts. That was a good one. I really like how easy you could pop your back. Now let's see how much you pay attention. What did you just suggest? Huh?
You're changing the name.
No. I'm not talking about that. I'm talking about what bone you just popped in your back.
Oh.
I taught you the other
I
day.
don't remember.
SI joint.
It's my backbone.
It's not your backbone. It's the SI joint, the sacroiliac joint.
Is that some more of the PhD coming out?
Well, my PhD is computer science, not anatomy.
Doesn't matter.
I do have a broken back though, so I've spent my time on a chiropractor's table. So I could be a chiropractor, I think.
Here, it's just like, oh, I'm sorry.
I don't know. I would say I have a pretty good knowledge of all the different chiropractic things. I mean, obviously not full blown. I know exactly where to push and stuff, but I kind of know the different spots. I pop my own neck and back and stuff like that. Make myself pass out sometimes. Let's hear. This is we're gonna get the occiput. Occiput's right at the top of your spinal column, kind of right where it meets the skull. So we go way up high. Oh. All right. So we moved one past that variable name, and then we're going to return var name. All right. So this very first time through, what does this method do? It returns room, but leaves our program counter sitting right there, beyond it. Make sense? All right, so let's go back to our Json parser. Now, if I am in parse cave, I happen to know in our language Json we have two different kinds of variables. We have rooms and we have treasures, right? If you look through our cave.dat here here's a variable name room, here's a variable name treasure, variable name room, variable name treasure, room, treasure, room, treasure, room, treasure. Those are the only two variable names we have in our entire Json language, right? So we know that find next var name will return one of those two. But we happen to know, since we are currently in parse cave, that it's going to return room, correct? Or the person wrote bad JSON. So we can assume they wrote good JSON. So we're going to go ahead and we're going to move past the entrance room variable name. And we do this by calling this dot find next var name. This guy does return a string. We don't need it. We know it's room. And we know now that we're positioned in the correct place. So we want to parse the entrance. And how do we do that? By calling parse room. So we're going to write a method, private void. Eventually this is going to be private room when we have it creating room objects. But right now it's going to be private void parse room. Okay? So what do we do right here? We call this dot parse room. All right, so now we are in parse room. We're currently sitting right here. I need to move into my room object. So that means I need to move to the opening curly brace and then add 1 to it. Correct? So pretty similar. By similar, I mean identical to what we did at the beginning of Parse Cave. Move to the opening curly brace for this room, because we're going to move to the beginning of the value associated with this var name, and then move 1 past it. Position ourselves before the first variable. Why did I say with this? Within this room. Within this cave up there. So we'll move to the opening curly brace, then move 1 past it. Now we know right now that if we call find, if we're just following our code, if we call find next var name, we'll go ahead and do it. String var name is equal to this dot find next var name. We know that var name will be equal to treasure. Because what we did is we positioned ourselves right here. We moved past, we went to the opening curly brace, then moved 1 past it. Find next var name is going to find us treasure. Correct? What do we do when we find a treasure? We get its value. Okay? So we'll call it parse treasure since that's kind of consistent with what we're doing for the other ones. So we'll write a little method here. Private string parse treasure. If we just called find next var name, we know, and it happened to be treasure, we know that we're currently positioned right there. So to get the value associated with the treasure, we need to move to the opening double quote, capture the whole value, move to the closing double quote, leave ourselves 1 after. Make sense? So almost identical to find next var name. We're looking to find the next var value, but we're going to do this inside of parse treasure because that's the only. We have 2 kinds of values. We have a string, so parse treasure is the same thing as find next value, because the only other kind of value we have is a room, which is parse room. Okay. So parse treasure, move to beginning of treasure value. So that is this dot move to char double quote, this dot cur pos plus plus. So we'll move right past that. So we should be sitting on the very first character of the treasure value. Now we'll create a string up here. It didn't matter if I created it before or after, but I like making my variables at the top of the method. So I'm going to create a string, treasure value. We'll start this off at the empty string. Then we'll say while this dot JSON dot char at this dot cur pos is not equal to a double quote. Treasure value plus equals this dot JSON dot char at this dot cur pos, and then this dot cur pos plus plus. After this while loop is done, we know that we are sitting right there. So I need to move one past that. Whether that's a comma or whether that's a space before our comma, doesn't matter. I just need to move off that closing double quote. Make sense? So our code that we're writing does ignore white space as of right now. That's why we're moving to characters we know we expect. There could be 4,000 spaces before this comma here. Doesn't matter. So after I've done this, cur pos plus plus. Move one ahead, then we can return treasure value for parse treasure. Make sense? Now, a couple things I want you to notice what we're doing while we're doing this. First of all, what we're writing here is not easy. This is a fairly complex program we're writing. But hopefully you're noticing that all hard programs are made up of a bunch of easy parts. Nothing we're writing here is difficult. The algorithm that we're doing to walk through it is complex because it's relatively big relative to what we've done before, correct? That's the hard part, not the actual code we're writing. The other thing I want you to notice is how I'm going about writing this. I'm a big advocate of letting your solution grow. So I'm taking legal input to our program and I'm literally walking through it and I'm creating new methods as we need them, as opposed to trying to conceptualize the entire thing beforehand. This will work for projects up to a certain size when you're working on them either individually or in a group of two. The second, and this kind of bleeds into something, you guys are in software engineering right now, right? Correct? Okay, so one of the things you talk about in software engineering is probably some of the different ways of planning software projects. Do you talk about agile software development at all in there? Or you just talk about the typical software development lifecycle? Okay, so one of the things that you're assuming in the software engineering class is kind of a larger team, not one or two people. You're thinking like, okay, I'm working in a group of 4 or 5 people, or even larger when you get out in the industry. And now this isn't something I can just solo go at and let it grow and hope everybody else knows where I'm at. Correct? This is something now that you have to do a lot of pre-planning because everybody's working on a different widget. And then those widgets come together at the end and they somehow build a robot or solve the problem, whatever. You get what I'm saying? So I'm not advocating a different style of software engineering. I'm just saying that your approach when you're an individual programmer may be different than your approach when you're programming in a group. Okay? In this particular case, since we're writing this ourselves, growing it as we go through some legal input is very beneficial because conceptualizing this entire thing, even though we look at it and say, oh, well, this isn't that much, there's quite a bit of detail going on in here. And if we just try to conceptualize the entire thing in our head, that might be difficult. But as we walk through this, we're going to start seeing patterns. For instance, in a second, we're going to see, oh, we have a variable named room. What do? Parse room. Do we have to do anything special? Nope, because what does parse room do? It moves to the first opening curly brace and then one past it, just like we did right here. From here, we move to the first opening curly brace and one past it. We don't even have to write that code. We already wrote it. So we're going to start seeing our patterns evolve here as we walk through there. All right, so right now I was here, I read in the value of treasure and left myself right there. So up here in parse room, I just got the next variable. And we happen to know, because we can see the code, that the first variable we run into in this room is a treasure. Nothing says that it couldn't have been a room first. We just know that treasure is going to be one of the variables inside of a room. This did not have to be ordered in this way. We could have had this room value before treasure. Okay? So, if var name dot equals treasure, if that's a true statement, if we just read in a variable named treasure, what do we want to do? Call this dot parse treasure. And here we'll just create a local variable here for storing the treasure value. We'll come back and deal with this more later. So we'll get treasure value right there. Don't worry about the scope of that right now. I'm just putting a placeholder. So we'll grab the treasure value. Else, if, even though we know we can just put an else, it's not a treasure, it must be a room, right? But we'll say else if var name dot equals room. What are we going to do? Call this dot parse room. That's what we do when we find a room. Correct? Okay. Now, back to our cave. What's a room? A room is a collection of variables. We should have exactly one treasure, although, I mean, if we had 10 treasures in there, it wouldn't be a big deal. We would just, whichever was the last one we processed, that would be our treasure value. But we have one treasure and then 0 or more rooms. So we can generically say that a room is a collection of variables and their values. Correct? And we already have the code for handling the two different types of variable types. Treasure we handle this way, room we handle this way. Now we need to just make sure we go through all those variables for this room. Okay, now what I'm going to do just for the sake of our output here, the beginning of parse cave, I'm going to say system.out.println starting cave. At the end of parse cave, I'll say ending cave, kind of building sandwiches here. Beginning of parse room, we'll say starting room. At the end of parse room, we'll say ending room. And we won't deal with treasures at this point. We kind of want to see the structure from the recursive nature of this. Getting back to what Val said. Best answer out of everybody was pointing out the idea that JSON is a recursively defined language. Okay, extremely powerful for what we're doing right here. Because we're about to see that we don't need to write a whole lot more code. Much more, well, a whole lot more, well, whatever. We don't need to write much more code in order for this to be done. Okay? The next thing we need to do, though, is we need to make sure we can identify when there's more variables. So if I'm right here, right at the beginning of my room, so that's when we moved to the opening curly brace, then moved one past it. How do I know that I have more variables available to me? What litmus test could we put into play if that's the object I'm currently looking at? How can I say there are more variables? What would the question you would have to ask be?
Furthermore variables.
That's going to be the name of the method we're going to call. What does the logic in that method need to check? I want you to look at this code. We know, as human beings, that there are more variables. Why? Because we have a comma. Correct? How do I write the code to check for that comma? We have to deal with that comma in conjunction with something else. How do we know we're at the end of an object? Closing curly brace, right? So if we have a comma before our next closing curly brace, we have another variable. Is that a true statement? So we're going to write a quick little method. I'll put it right next to find next var name. We're going to write a private Boolean has more variables. So this guy's going to need to calculate two things. The position of the next comma relative to where we are right now, and the position of the next closing curly brace relative to where we are right now. Now the reality is it's not going to find this closing curly brace. It'll actually find this closing curly brace. But that's fine because that guy comes way after our next comma. Make sense? You have another variable as long as the next comma comes before the next closing curly brace. So we're going to have two different loops here. We're going to say int comma pos. We'll start this off as this dot curpos because we don't want to change curpos here. All we're doing is asking the question, are there more variables? If there are, we'll deal with it. So comma pos is going to be while this dot json dot char at comma pos is not equal to a comma. We'll say comma pos plus plus. Now, we do need to be careful because we potentially may not have any more commas. Therefore, we'd walk off the end of the string. So we also need to say while comma pos is less than this dot json dot length. So while both of those things is true, or both of the things are true. So as long as comma pos is not off the end of the string, and we have not run into a comma yet, increment comma pos. If it ends up going off the end of the string, no big deal. Comma pos will be equal to the last bucket of our string, which means that we'll probably find a closing curly brace before we get to that guy. Does that make sense? So serves the same purpose. So this will position comma pos for us. I'm going to steal that code. And we're going to have a CCB pos, closing curly brace pos. That'll also start off at cur pos. We'll keep going as long as CCB pos is less than the length of the JSON or the position of our closing curly brace. CCB pos plus plus. What do these two loops do? This guy sets comma pos to the position in JSON where the next comma is. This guy sets CCB pos to the position in JSON where the next closing curly brace is. We know we have more variables if comma pos is less than CCB pos. If we run into a comma before the next curly brace, we have more variables.
Change it in that parameter.
Change who?
Char it. You gotta.
Oh, thank you.
Yeah.
I was testing you.
Did we pass?
No. Okay, CCB pos. Just give me 30 more seconds here. So has more variables. So now, inside of parse room, all this crap we have right here, while this dot has more variables. As long as we have more variables, we're going to keep reading in variable names. Does that make sense? As long as we have more variables, read in variable names, either process the treasure, process the room. So when we run this, we should see the recursive nature of this. CSP.parse. The output should be begin cave, begin room, begin room, begin room, end room, begin room, end room, end room, begin room, end room, end room, end cave. Make sense? That's the recursive nature of JSON. I know we rushed that at the very end there, so I'll explain it on Thursday, kind of how that worked. But notice how easy that was in the end. I realized the path was a little convoluted, but we didn't write any difficult code. Everything was just while loops and incrementing an integer. Okay? See everybody on Thursday. And in case any of you heard from one of my other classes, I'm leaving for a conference at Western Illinois University on Thursday, but we will have class. I'm not leaving until the afternoon. So lucky you guys. So in case your Friday class with me has been canceled because of this conference, we still meet on Thursday.
I don't know. I hear traffic's pretty bad now and then. You might be